Hi and welcome back to another session from your LPIC, LPIC 1. I'm Jody, Geeking with Jody, and we've reached 110, only one to go. Set up host security. The whole 110 is about security. The module 2 is about set up host security. The weight is 3. It's important. You should know about the shadow password file, turn off network services not in use, and understand the role of TCP wrappers. There are lots of things that you should know about, but we will cover them. No worries. The problem here is it's a little bit diverse, talking about different things in this session, and I'm going to record only one video because it's easy, and also some of them are deprecated. Yes. And good news, many of them are already covered in previous sessions. This is a good thing about learning. If you remember, in the first sessions, I always used to say that, okay, we will talk about this later. You will see this later. Let's do this, but later I will talk about how this is actually done. Now, we are repeating and repeating. As you've already seen, you already know this. We've already covered this. So you're going forward and learning more and more. Shadow passwords is already covered truthfully, I'm sure. But let's go over it once more. Cat etc passwd. This is the file which contains my passwords. All users, their passwords. Does it? No. This is my user, Jody. My passwords field says X. Then my ID, my name, address, whatever, my home directory, and my shell. So when I log in, this is the program which runs. But where is my password? It's X. On the older days, users' password were actually written here, which was very funny because we were able to read password and recover passwords. If you don't believe me, please believe me. Later, they said, okay, this is too easy. They started inserting people's hashed password here instead of the actual password. But after some time, they found that, okay, hash passwords are not safe because I can go and hash the word password, see what it is, search different Linux files, and if I saw that, I know the password is password. Very funny. So nowadays, they moved this password to the file called etc shadow. The reason is this file should be readable for normal users because I need to be able to find my home address. I need to be able to change my shell and other stuff. This should be readable for users. So they put an X here, which means that the actual hash of the password is in the shadow file, and the shadow file is not readable anymore. As you saw, I was able to cat passwd, but I cannot cat shadow. Only root can see shadow. And here you can see that Jody has a password which is hashed. Its time, expiry, other things you already seen. So this is the usage of shadow passwords. You also saw that here many users do have this nologin as their shell. When you have this nologin, it means this user is not allowed to log in. So if you want to prevent my user from logging into a shell, you can change Jody's shell instead of bash, zsh, fish, ksh, csh, whatever it is, to in my computer user bin no login. This way the computer will know that this user should not log in into the system. They will log in, this program will run and exit, and the user is not in a shell anymore. Please note, in this case, people can FTP to the server, can use the mail, can use tunnels if they don't log in with -n switch. You will see later on the next section, and other stuff. So you are not locking the user. If you want to lock the user, you have to lock it using passwd-l. There is also one cool file, which is not there, hopefully. etc nologin. You can create it if you want. Ouch. Sudo vim etc nologin. No. Nobody logins for some time. Now the file is there. So whomever tries to log in into the system will see that message and the login will be disabled. I created a new shell. I will connect to that machine. This was the... What is this? You saw an IP address. Okay. If I log in here, I will provide my password. The system says, no other logins for some time. Close the connect. The same thing will happen if I try to log in from a console or from the computer itself to the shell. And for sure, removing this doesn't mean removing these lines, because now the file is still there, but there is nothing in it. If I want to revert back this change, I should delete this file. Now the file is not there and people can log in again. Cool. I'm sure you really liked it. It was fun. etc nologin. And this is another example. If you want to prevent a user from logging into the shell, you can just change its shell to nologin. Here I've said sbin nologin. In my computer it was user sbin nologin. Anyway, these two were fun. But let's go to another important discussion about a super server or TCP wrapper. This is something which wraps TCP connections. Let me explain from the beginning. This is your computer. As we already talked, when you have a server, for example, an HTTP server to answer web requests, it is running here. And it registers itself to the OS with port 80 or 443 for HTTPS. Now, when any connection, any computer on the net reaches your computer and says to your OS that I want to work with port 80, this is the program which answers it back directly. You can have different programs and they can listen to different ports. Even you might have a malware here which listens on port 4040. Who knows? If this runs, it starts running as a daemon, tells to the operating system that I want to listen to this port, and from now on, whoever reaches your computer on this port will be delivered to this program. Controlling this is a little bit difficult because whomever can start and just listen. Okay, if you don't have the root access, you cannot listen to the ports under 1000. But above 1000, up to 64,000, blah, blah. Anywhere, anyone can listen. This is why we used to have super servers, or as it's called, service dispatchers, or TCP wrappers. How do they work? A super server is a program which runs here and registers all the required ports to itself. 80, 443, 631. And is configured that if someone reached the computer and wanted to work with port 80, it should be delivered to HTTPD or Apache, for example, a web server. If something came and wanted to speak with 631, deliver it to this program. If you had a malware which wanted to listen 4040, it would ask the system admin, please configure your super server to accept 4040 and deliver it to me. Not very likely to succeed such a request. So this is why programs like inetd and later version xinetd were invented. There were a wrapper around your all TCP servers. This would accept the connection, will talk with servers and answer back. So security is one reason. Another reason for using them were resources. Old computers didn't have lots of CPU and RAM. So you had a server with 1 megabyte of RAM and you wanted to serve FTP, Telnet, web, and Gopher. Old school. The computer was not able to have all of this all the time in the memory running and listening. So xinetd was there. If someday someone came to your computer and said, I want to work with the FTP, this would spawn an FTP server, get the answers back, answer the request, and then FTP would go down. Less resources. You didn't need everything to be running all the time and listening for the connections. This was the reason that we had these wrappers. Nowadays, very, very few systems do use them. Although systemd has its own wrapper, as always, it has everything. This is a sample configuration from xinetd. It says, I have a service, it is called Telnet. Disable it, no. Flags reuse. Socket type is a stream, which is TCP. Other configurations, user is root. This is the server. If someone came to you and wanted to do an FTP, spawn this server, and no access to this IP range, and also access time is from 9 to 16. Very easy. You can easily configure every service to run on a specific time on a specific network. This is much more difficult if you want to configure them one by one from the service itself, even if they have this. But as I've told you, nowadays fewer and fewer services use these methods. xinetd should be part of the programming. You can check for libwrap and see if your program respects wrappers. If it does, you can have xinetd. Although nowadays, as I told you, very, very few distros do still use this. If you want to check this, I have this here, LDD. You can check, for example, LDD shows the libraries used in a binary. So you can say user sbin vsftpd. It shows all the libraries in vsftpd, and for sure there is libwrap. Yes, it uses libwrap. So you can use this vsftpd, which is a very secure FTPD, an FTP server, with xinetd. There are also two important files to know about: etc hosts.allow and etc hosts.deny. If a program respects vsftpd, you can add something like this in your, for example, etc hosts.allow, and it will tell the xinetd to allow vsftpd only from this. Only. Because the file is called allow. And you say allow from here. So this allow from everywhere else. If you use the file etc hosts.deny and put a service and an IP range there, it would mean that deny from this address, which means allow from every other address. A silly question and fun question from naughty students is, oh, what happens if we put something in both of these files? I don't know. You can go and try it, which is a nice exercise. You can install vsftpd, make sure that you can FTP to your machine. Then I think even maybe you need to add xinetd. I don't know. Try it. It's a silly question. Sorry. And it's fun. I would ask it. And then I would try to do all of this. Then try something to etc host, see if it works or not. And then add it to the TCP allow and see if it works or not, and other stuff. Last word about TCP wrappers is that nowadays it is not being used that much. Although, as many other things, systemd is trying to conquer this land too. If you remember, most of our services, for example, SSH service, is called ssh.service in systemctl. So I can do sudo systemctl status ssh service. Obviously, it is running. It is active and running. It is a service. So ssh is up and running. We can check this with fuser 22 TCP-v with the root user, and you can see that TCP is being answered by SSHD. You saw this command in the previous section. This is how we can check if a service is running or not. If what is listening to this port, sorry, file user on port 22, it says, okay, SSHD is listening to this port. What we can do, sudo systemctl stop ssh service. Now the service is down. No one is listening here, although I still have running services. Now I can do systemctl sudo start ssh service was the service. I can say start SSH socket. Now systemd is working as a wrapper around this. If we do the fuser again, you will see that now systemd is listening to the systemd is listening to this port. It works as a super server. Now systemd knows that if someone comes to the port 22, I should answer it, but it knows that later I should provide the connection to SSHD. Sudo systemctl, just to fix what I did, start SSH service and stop SSH socket. So everything is working normal. This is what you should know about services. There is one more section which I talk about in the same video because it's very short, and it's about removing unused services. This is very important. Some people say, I've installed one Linux and it has every single package and command and service. I'm the god. No, you are not. You are an idiot, unless your boss is an idiot to have such a service, or you are practicing something, or you are not an idiot. I don't have the right to tell you idiot. Maybe. I don't know. Anyway, in the hacking world, one of the most important concepts is the attack surface. You have to make your attack surface smaller and smaller as much as possible. If you have a Linux with too many services running, games, and lots of things on it, a hacker can attack to any of these, and you have a very, very large attack service, just like the opposite to the dead store. In a better word, if you want to be safe, you should have a very, very limited attack service. If you are a web server, only your web server should be exposed to the outside world. Even in some more secure places, they say your web server is here and it should answer back only and only to one IP. That IP will accept requests and will forward them to you. So you have one more layer here and your attack surface is even smaller. So it's important to check your computer for unused services and remove them. One good command here is service. You can do sudo service status all. Show all services. My computer do have these services. You can check them. If one of them is not needed, you can remove them. For example, sane is for scanners. I don't want to scan anything on this machine. I can remove this. Although this is down, but it's better to remove it if you don't need it. If you're on a Red Hat based machine, you can remove a service like this. Sudo check config vsftpd off. Or you can on a Debian machine say sudo update rcd vsftpd remove. You should know all of this from the beginning session about the inits, how the system boots, what are different inits, and those kind of stuff. For sure, you can do the same on the systemctl. Systemctl status will show you all the services if you run with the sudo. All the services running on this computer. Caller D, container D, cops. We can stop all of these on a server, not containers. If you want to check all, you can do with this. Systemctl list all the units when state is active and type is service or socket, as you know. These are the services you can check and remove if not needed. To remove, you can do a disable, which means it won't start when your host comes up. You can stop, which means it will be stopped at the moment, or you can disable now. Disable during the reboot and now. And I'm sure I'm sure you don't remember, but you may remember if you are a good student. In the beginning sessions, we talked about system 5 init system, which is being replaced by systemd. On system 5, we had etc inetd directory and some files there, services. We could start, stop, or do different things with them. They are still there. etc inetd. I have these. I can manage them from here. Although some of these are being managed by systemctl nowadays. But you should know also about this. Refer back to the first sessions about how system comes up, how init works, and these stuff, and you will recall all of this. The last, you should know about etc init tab file, which is part of the init system on system 5 systems. If you don't understand any of these, it means you haven't watched the beginning videos, but that is fine. On init tab, there are different lines like this. It says one specific ID on these run levels, do this action on these processes. For example, the ID is 1, whatever. On run levels 2, 3, 4, and 5, respawn this command. So run this command. If this is killed, rerun it on these run levels. And there is one important file there, which is this one. It says ID init default is 3. So when systems boot to the init 3, which in some systems the graphical mode, in some systems the text mode. Sorry if it was a bit confusing, but return back, watch the initial videos about the inits, how system boots up, and this kind of stuff, and you will have a much more clear understanding. Although I'm sure you know whatever is needed for LPIC in this section. Have fun.